All right, welcome everybody to another episode of our Puget Systems podcast live Q&A show. I love that. I love doing it. This week, we have our labs team joining us today. A bit of a roundtable discussion about the recently released 3080 Ti, and I guess kind of the 3070, but I don't think we've really bothered with it, right?
We haven't seen it.
Yeah. So okay,
yeah,
3080 Ti. Right on. I feel like the general consensus is it's basically a 3090. Is that accurate?
with half the VRAM.
Yeah.
It's a 3090 with only 12 gigs of VRAM instead of 24, and it's kind of
yeah. Well, I guess we'll just kind of dive right into it. Matt, I feel like you probably have you and Kelly are probably going to have a lot more of charts and things, I suppose. But I guess we'll just start with Matt, and then we'll work our way around. Where would you like to begin?
Sure. Yeah, I guess I can go through. Yeah, you want to bring up my screen? Because I think a lot of this stuff, like what you were saying, like it's basically a 3090 with less VRAM. So a lot of my stuff, and I think a lot of ours it's like, yeah, it does exactly what you would expect. So like After Effects, not huge on the GPU, but it basically scored exactly the same as the 3090. And After Effects, you don't need a lot of VRAM for After Effects. So the VRAM, yeah, I guess it's nice over the 3080, but it's, what was the percentage here? Percentage over the 3080, 5% higher performance. So it's like, great, you can get 5% higher performance for, I think it's like $500 more than the 3080.
Wow.
And you get some VRAM, great, whatever. I think most people who are like After Effects, they stick down to like 3070, 3080, if even that high, and spend all of their money on the processor or RAM, probably more on RAM and storage. So After Effects is like, yeah, it's an okay card. With supply as it is right now, like if you can get one, great, might as well. It also can be for like rendering. It can be really, really nice. I think, Kelly, did you have like rendering stuff too? You were going to talk about? Okay, so I'll leave that for Kelly to talk about. But a lot of After Effects people are starting to do more with like Redshift or Octane. That's just part of their workflow. So in that case, like, yeah, getting 3090 level performance and saving a little bit of money is great. Because a lot of times with like motion graphics, you don't need a ton of VRAM even for that stuff. So
that's interesting to hear, because you'd think with VFX and things like that, the stuff that After Effects handles, you would think it would rely a lot more on the graphics card.
Well, like After Effects itself,
or I suppose just for what it's used for. It would the assumption would be that it would be more GPU accelerated. Yeah,
and they have been making a lot of work, or they've been doing a lot of work to get GPU acceleration better. But they've really succeeded. There's a lot of stuff in After Effects now that's GPU accelerated. It's just it's so fast on like any GPU that you immediately go back to being CPU bottlenecked no matter what. So it's like, yes, it's there. But the reason you don't see a huge performance bump, even from like a 3060 up to a 3090, is because the GPU is just not the bottleneck. And there's only so many things that they can accelerate with the GPU effectively. I don't want to get too off on a tangent here, but they're doing a lot of work with what's called multi-frame rendering right now. It's even in the beta that you can just try it. And that should make higher core count CPUs better, which should in turn make the CPU not as much of a bottleneck for the GPU, which should let higher end GPUs be more effective. So hopefully when that feature comes around, we'll start seeing that like you can get more benefit not only out of higher end CPUs, but out of higher end GPUs as well, just because, once you take whatever is the bottleneck and you make that faster, it should make everything else, kind of come up along with it.
Yeah, I see some of that too, Matt, with the HPC stuff. The GPUs are so fast that the CPUs just bottleneck things.
Wow.
Yeah.
Yeah, it's a weird one.
Yes.
If you make your GPU performance too good, it looks like your GPU performance sucks. Wow. Because you would look at this chart and think like, oh, like no matter what, it's going to be terrible. Why do I even need a GPU? But if you didn't have a GPU, performance would be way down here or something. So it's worth it to have one, but it's not a bottleneck, so you don't have to go too high. It's kind of like NVMe drives. It feels like it's kind of that way in a lot of things right now, where like if you don't need more throughput than what like a SATA SSD can do, getting a drive that does 7 gigs a second read doesn't matter, because that's not the bottleneck. Like, yeah, it's fast, it's super fast, but it's just not a need.
Yeah. Huh. All right. So go ahead.
Yeah, so move on to another one is Premiere Pro. Premiere Pro, it's kind of very similar. There's a little bit more of a kind of a gap between the 3070 and below, and then there's a bit of a jump up to the 3080 to the 3090, and those are all, they're effectively the same. What's the percentage difference? 4% faster than the 3080, so it's really not much about performance. Premiere Pro, though, is an interesting one for the extra VRAM. So Premiere Pro, if you're doing 8K footage and 8K timelines, which, man, it's becoming more and more popular with, Blackmagic cameras are getting higher resolution, fairly cost effective. There's still all those red cameras and everything. But 10 gigs, like with the 3080, it's cutting it close with 8K timelines. You can do it, and that's actually what we're kind of is kind of our entry, I guess, I believe for our 8K system is the 3080 with 10 gigs. But man, if you wanted to add like some noise reduction and a few other things, it just it can be not enough. And running out of VRAM sucks. Like there's not workarounds for it. It's just it sucks, and now it doesn't work. So the extra 2 gigs, I think, is the bigger thing for Premiere Pro. If you're doing 8K timelines, that extra 2 gigs can be just enough to put you into the level of being comfortable rather than just being really tight. Because you really don't need the 24 gigs on the 3090 in Premiere Pro. It's just, if you'd have 12 gigs, that's probably enough. So for someone like Premiere Pro, if they're looking for the highest performance GPU and a GPU that'll have plenty of VRAM, 3080 Ti is a great option. On the other hand, the thing that kind of gets me with the 3080 Ti, and this is kind of a general thing, is it's only $300 less than the 3090.
Mm-hmm. Yeah.
So it's like, for $300, you can get twice the VRAM, and then you just never have to worry about VRAM.
Right.
Ever. You can do whatever you want, and it's fine.
And I feel like that is kind of it's a cheap enough upgrade where you're when you're looking at some of the other parts that you could be spending money on, $300 seems like not that much.
Well, and if you're going to be buying a GPU like one of these ones, the 3080 Ti or the 3090, you probably have a $5,000-$6,000 workstation at minimum.
Right.
Call it a $6,000 workstation. What's $300? That's it's a very low percentage of the total cost. And now, hey, you've got double the VRAM. And like the 3090 has a beefier cooler. It's triple slot instead of dual slot, but it is a beefier cooler on the NVIDIA Founders Edition, at least. Once you get into the third party, it's all, whatever. But you do get that beefier cooler, which is better. Because I know in our testing and qualification of the 3080 Ti, like it's louder and it's hotter than any of the other cards, because you're basically taking a 3090 and giving it a 3080's cooler. So it's going to be hotter. Because actually here, let me go up to the top. Since we're kind of talking about price, this is how it spreads out in terms of price. So it's it's a big jump to go from the 3080 to the 3080 Ti. That's $500.
Sure.
But then from the 3080 Ti to the 3090, it's only $300. It's kind of a little bit odd to me how they did that pricing. I'm surprised they didn't make it right at $999 or something.
Yeah.
I think it doesn't always give the accurate performance increase going from the 3080 to the 3080 Ti for that price difference. It's that one's a little strange, but if you were considering a 3090, it might not change your mind to just stick with the 3090.
Right.
Yeah.
Yeah.
It's again $300.
Yeah, you're not saving that much, so
right. It's like an SSD.
Yeah.
So
All right, what else? What else you got?
Yeah, that's Premiere. The only other one I looked at, because I didn't look at in the past. I've done a lot of stuff with like Photoshop and sometimes Lightroom, but I've just realized that Lightroom 1 is just like no, it never has really used the GPU all that much.
Right.
And then Photoshop, it does, but man, our charts are always just like a flat line with the GPUs. Same thing we were talking about before. Like it's just not the bottleneck. So like whatever. So I just skip Photoshop this time because like,
nah. Those are my favorite boring articles though.
Yeah, where you have to tweet out about it, put it on social media.
Yeah,
is the 3080 Ti faster? No, it's just all the same. So I skipped it.
So one paragraph article.
Yeah,
it probably should be.
Links back to your 1070 article.
Then Houston comes back to us like, "How come these articles aren't getting engagement, guys?"
It's because they're boring.
Who cares?
I mean, it's good to do those tests, I think, every once in a while. So I probably will, like, even in like Photoshop and Lightroom, once every year or two, or like every other application version. I think it's worth it because you never know what they're going to do and then not put in the patch notes. Like that happens all the time. It's like, oh yeah, this wasn't in the update notes, but hey, surprise, like GPU acceleration is way faster. Come on, put it in the update notes.
Right.
Okay, well, my last one is Resolve, which is way more on the GPU. There's so many effects that are GPU accelerated. You need way more VRAM in Resolve, to the point, actually, that the 2 gigs of VRAM isn't actually enough to make a difference in Resolve. Like in Premiere, it puts you right over that threshold if you're doing 8K. Mm-hmm. And Resolve, 10 gigs is plenty for 4K, but you really need like 20 gigs of VRAM to do 8K. So if you're going up to 8K, the 3080 Ti isn't going to cut it anyway. So you really would need the 3090. Performance-wise, good performance bump, though, over the 3080. Yeah. Just a little bit behind the 3090. So if you are doing like 4K work, I don't know. You could argue just do the 3080 Ti, save a little bit of money, and do it that way. I mean, a lot of people with Resolve, when they get into high-end systems, they're going to be putting multiple cards in. And I'm not sure what we've qualified as far as multi-GPU on 3080 Ti. I bet we'll probably have to limit it to 2 cards since there's no blower styles.
Yeah.
That's what last I heard Josh was leaning towards, was limiting it to 2.
Yeah. So it's a good card, solid card, fast. Again, not going to put you up into the 8K range because of the VRAM, but for like 4K stuff, it's very, very solid. It's a great card for this stuff. So that's really all my like hard numbers and all that kind of jazz that at least I went through in my testing. I am curious to see what the 3070 Ti will do. Yeah, because it's same VRAM, right? It's still 8 gigs. But I'm really going to be really curious to see, like, is it going to be here? Is it going to be up here? Where is it going to be? It could be a nice enough card that, like, maybe we wouldn't even carry the 3070. We just do 3070 Ti, 3080 Ti. I don't know.
The core count is so minor over the 3070. I'm curious to see what it actually does.
Oh yeah, I had it here. But it's 0.07 gigahertz boost clock higher.
Whoa.
Right? Could make a little difference. So yeah, that one I'm curious about because I don't understand it. And I want to see what it does.
Yeah.
Like on paper, I don't understand it.
I want to hit this. This is kind of a general question that we got from YouTube. Bassam asks, what is missing for AMD to beat NVIDIA?
CUDA.
I'd say probably focus. Like they just, this kind of stuff is not their focus. AMD on the GPU side, they focus on gaming first, and that's really it. I think if they really want to compete, they have to decide as a company, hey, we want to compete in this market and actually do all the development for it. And they have to do a lot of work with OpenCL, I would say, to make it up to the same level as CUDA. Because anytime I've talked to developers about GPU stuff, developers love CUDA. Like, it's well documented. It works. It's well documented. I'll say that again.
Hey, that's important.
It's
having
super
dabbled
important.
in software development a little bit myself, comment your code. And documentation is super important. Think about the person that's coming behind you, because that person's probably going to be you.
Yeah, it's going to be you in a year, and you're not going to remember any of it. I think OpenCL has got to make a big jump. and it could actually not from AMD, but actually from Intel, because Intel's doing all their GPU stuff right now, and that's all based on OpenCL. So if they do a lot better on developing OpenCL, then AMD could benefit too, and that'll just raise all of it. But I mean, there's so much stuff out there, especially in content creation industries, that are CUDA only. Like a lot of rendering engines are just CUDA only. You know, none of my stuff is CUDA only, but man, it might as well be in some cases because AMD is just so far behind. And it would take a lot of work, I think.
Yeah, I think we skipped most of the GPU rendering when we did the AMD cards because everything needed CUDA. Like there just wasn't a point. So
yeah, that's the same way in HPC. The one thing, about Matt, what you were saying about the stuff from Intel, yeah, that's a big deal because Intel is really, really, really pushing on their ecosystem, and they have to have good OpenCL support. So that just community effort there will boost AMD. The other thing that's going to really boost AMD over the next couple of years, but it's going to take some time, is the development because of the supercomputers going in that are AMD based.
Sure.
They do have a compute card. What is it? What's it called? MI100.
Okay.
And that thing is purely compute, and that's going into what will be the fastest supercomputers in the United States, maybe in the world. One this year, and then another one 2023.
Wow.
And they're exclusively AMD, so it's AMD CPU and GPU.
Wow.
And that's a huge investment for the development community to make those things work great. So that will again boost the OpenCL, and that'll trickle down probably to where, you know, other vendors will go, ooh, okay, well, if libraries get developed and stuff like that, yeah, we might get better support.
Cool.
On that. But man, NVIDIA is just like really nailed in there deep.
Yeah. Well, the other thing with NVIDIA too is they've got a lot of features that are NVIDIA only. Especially what comes to my mind is like all the tensor cores and stuff, all the stuff for AI and stuff, accelerating AI. Because man, AI is everywhere in all these apps. I don't think people realize how much stuff in like Photoshop is AI. Like, it's a lot.
Yeah.
And it's being more and more and more and more. Like Premiere Pro has all this stuff about like audio ducking, where like it can tell what's voice and what's music. It can do all this other stuff. Like all that stuff is just going to grow. And NVIDIA is on the forefront of, you know, anything AI related. And so their stuff is just always going to work better with it. And unless AMD makes a huge investment in it. And I think that's just hard for AMD. Like, I don't know how big AMD really is compared to NVIDIA, but like, or they're like R&Ds, but it always feels like AMD is like the, you know, from behind on the GPU side. CPU, I think they're well up there. They're AMD's in the lead on the CPU side, but on the GPU side,
Well, I think on the GPU side, at least for my stuff, for gaming and rendering, the big thing they have going right now is that they are the GPU inside the new Xbox and PlayStation. So they're having a lot of game development focus on their GPUs, which will help with real-time stuff. Probably it's not going to help rendering a whole lot because that's still going to be CUDA based. But yeah, I think that's going to help them. And I feel they're in a similar situation now with the GPUs as they were in the CPUs like a generation or two ago.
Oh, sure.
Where like, that new GPU is good looking, it's doing good stuff. It's not quite the top yet, but it's a good option. And that's what they did with their CPUs. They got kind of good, got a little bit better, and then they eventually won everything. So hopefully they can do the same thing with GPU. That'd be nice.
I agree.
I'm still concerned about one supply. Like, I know supply is bad for everything, but like we can get NVIDIA cards. Like we're keeping up with our orders on NVIDIA cards. AMD cards, I've had a 6900 XT on our order list since it launched, and we still don't have one. Like, the only way to get one of those cards is to like have a bot or get very, very lucky or buy it for like 3 times markup from a scalper. So like I feel like AMD their manufacturing isn't keeping up. I'm not sure why. I don't know. And also the reliability and stability still always concerns me with AMD GPUs. It's funny because like we don't sell them. I mean, we can't get one. So like we don't have any firsthand. But man, I'm on Reddit a lot on a ton of different content creation subreddits and AMD subreddit and all that stuff. And for how few cards I feel like there are out there in the wild, there's a lot of people posting problems and trying to find solutions for driver bugs, hardware stability things. So that has a big red flag for me from AMD on the GPU side. Like, man, if your stuff isn't solid and you're kind of coming from behind, it's going to be really hard for you.
Yeah. Dang.
Wow. We give them a couple of years. It could really change a lot.
Oh yeah, first gen Threadripper was rough.
Yeah,
first gen Threadripper was really rough, and now we're on third gen, and it's terrific.
Really good.
I definitely hope we see a similar trajectory with their GPUs that we have with their CPUs, and it kind of feels like that's kind of the internal focus that they did was like, hey, we're gonna just double down on CPUs right now and nail this. And now that they're kind of on the top of the heap, they can kind of just maybe slow down a little bit there and then focus on graphics cards. I'm hoping that'd be really cool.
I mean, even if they can just get on par, that'd be great. Just
right,
competition helps everybody. So
yeah, which they are in gaming, and which again is like their focus. And I would say AMD's on par with NVIDIA,
as long as you don't do ray tracing.
Yeah, as long as you don't. Aren't they starting
to
get
that FLSS?
I mean,
coming,
they
right?
have ray tracing. It's equivalent to last gen ray tracing on current gen hardware. So it's just slower. So I mean, you already take a big hit enabling ray tracing on an NVIDIA card, but then you do it on the AMD card and you drop a quarter of the frame rate. It just tanks.
Wow. Yeah.
So yeah, it does it, just not very well. But I mean, that's their first try. NVIDIA's first try wasn't great. So,
all right, Kelly, what do you got for us?
All right. Well, we can start off with rendering. I mean, what did you expect? It's 3090 with smaller RAM. As long as you don't need the 24 gigs of VRAM to house your scene, because that's the big thing for rendering, especially high-end rendering. If you have a scene that's that large, you just need to get the more VRAM.
Sure.
It takes quite a bit to use up 12 gigs.
Okay.
None of the benchmarks we have can use that. So mainly because it would just be a massive download and Redshift and Octane and all them, they don't want to host a 20 gig download for everyone to try for the 5 video cards that are out there that support it.
Okay.
So that's Octane. It's almost neck and neck. Then you go to Redshift and it's 3 points behind the 3090. Decent bump from the 3080, which is pretty good. Then V-Ray in CUDA mode is pretty close. And then V-Ray in, I had to go this way. In RTX mode is about the same. So yeah, it's really is a 3090 just with lower VRAM.
Yeah.
So you just have to ask yourself if you need the VRAM, get the 3090. If not, 3080 is kind of an interesting option.
Okay. How common would you say it is that somebody would need the 24 gigs?
Not super common, but I mean, it's not hard to do.
Okay.
So it's not like
some of it.
It's not limited to only to Pixar and them. You can do it at home, but
can't you also get that if you're just not good at optimizing?
Yeah.
Can't you just I'll throw all this stuff in. I won't do best practices, and now I need way too much VRAM.
Yeah. Well, we actually see that a lot in Unreal. When I get to that that's what, especially ArcViz, not to call it all the architects out there, but some of the problems they have is because they're not optimizing things. Same thing with virtual production. They're just throwing cinematic quality assets that they would use to render normally in Redshift, and then put it in a game engine and be like, why isn't it getting 60 frames per second? I don't understand.
Because you have 5,000 buildings that are all
Right.
full res in the skyline.
Yeah. It's like game developers spend months and have people dedicated to optimizing every single part of the game. In fact, Unreal has a built-in tool that you can like set up a path for an AI to take throughout your level, and it will take screenshots of various places of like, this is where FPS drops and this is where this thing happens, and it shows you what is causing the problems and stuff.
Oh, that's cool.
Because you got to spend time to get good performance.
This might be jumping forward, but Unreal 5, isn't that like something baked in where like as you zoom out or whatever, it switches to lower quality automatically?
Yeah, that's blowing my mind right now. So it's called Nanite is the system that they created. And basically is down-resing a model as it zooms away. So that way a triangle never gets smaller than a pixel. Because that way it's just basically wasted information. Then if you have two triangles within a pixel, like you can't render a difference anyways. So, and it's just doing it in real time as it moves. And like when I was in a game development studio, like we spent days and days for every object we made, like making different LOD states for like, once it gets this far away from the camera, then you switch to this model. Once it gets this far away, then you switch to this model, and having to create all those by hand and create new textures for those that are lower resolution. And now it's just doing it. It's wild. So yeah, that Unreal 5 is going to be a huge game changer.
That's the demo of them flying through like the asteroid field, right?
No.
Oh, okay.
That's the one where like they're like it's like ruins or something, like desert ruins.
Yeah, it's like in a desert slot canyon type.
Yeah,
scenario.
Some like the magic thing.
I mean, I can bring it up and play it if you really wanted to. We'll see where we get. And,
so, the end. That'll be fun.
Yeah,
and we need and that'll lower VRAM requirements, right? Or is it still going to have to keep all the assets in VRAM?
It still has to keep all the assets in VRAM. I'm not sure how that's going to work. Actually, now that you asked that, because I'm assuming that's going to have to keep the base file at least, because it's not going to create a separate file.
So it might actually make it worse because people are going to become lazy.
Right.
Oh yeah, from performance wise, it'll handle it all.
Yeah. So one of the keys is in a game engine is to create instances of things where it's basically duplicate. So you have one object and then you create multiple instances where it's the same object. So it only has to load that object into VRAM once and then just displays it multiple times. That's something that a lot of like, if you don't do it correctly, now you have 30 copies of that object instead of one copy. And so there's still gonna be a way that you can screw it up.
Yeah, Kelly, since after listening to you talk about the game dev and especially the LOD, the level of detail, now whenever I'm gaming, I see when I'm moving through scenes and stuff, you watch those textures change.
Yep.
I never really noticed that before. But
or
that's what's going on.
Or you'll see like when you look at the ground, especially on ground, it happens a lot. Yeah. You'll see like at a certain distance, there's a line and it kind of changes to look a little different. And then a little further out, there's another line that changes. That's a system called MIP mapping, where basically you have like a 1024 texture by 1024. That's your texture. And then when you generate a MIP map, it creates a 512 version and actually sets that off to the side of this temp texture. And then a 256 version and then a 128 version. And your final image is this chain of different resolutions. And then if the engine looks at how far away it is and picks that section of the texture to render, so that way it's not wasting pixels the further on. That helps prevent like the moire effect and a bunch of other stuff.
Well, and the goal is to have it rendered before you notice it, but that doesn't always happen. Like I know
isn't that another thing to look for?
Yeah.
Isn't that like a major strategy in a lot of speed running, where they get glitches where they go so fast that it can't load in the model in time, so that's how they like glitch through walls and stuff. Is like if the wall's not there, it can't stop me.
Yep. Yeah, because it's trying to pull everything in at the right time. And yeah, if you can move fast enough, then you'll see it pop in, or you can get past it before it pops in.
So you need a slow computer to do speed runs so you can go through walls before they're there.
Yep. Or what was the other thing I was going to say about that? I totally forgot. Oh, the other thing you'll see is shadows and like ambient occlusion, like the little when things are kind of at an angle and it kind of darkens where they're meeting. You'll see that drop off at a certain distance. They'll only calculate that within a certain radius of the player. So that way they're not trying to calculate shadows that are, 800 miles away just because you can see it. But anyway, so talking about Unreal. So this time around, I'm working on creating separate scoring system for game dev versus ArcViz versus virtual production. That's still, I feel, kind of lumping too much stuff together, but kind of have to get
you got to lump stuff together at some point.
Yeah. Because like game dev, are you making iPhone game or are you making Call of Duty? Like it's not the same thing, but whatever. So for game dev, 3090 is lining up like you saw with every other benchmark. It's really close to the 3080 Ti is really close to the 3090, about 10% faster than the 3080. So yeah, for game dev, they don't usually go with a whole lot of VRAM because if your game needs 24 gigs of VRAM, then your target audience is very small. So yeah,
the VRAM, crisis guys, right?
Right. Yeah. If you can only sell to people that have a 3090, then you're going to get 100 sales maybe. So now we go to ArcViz.
Ooh.
We start to see a bigger gap. A bigger gap between the 3080 and the 3080 Ti, and a bigger gap between the 3080 Ti and the 3090. And that's because the scenes that I'm using for this, one of the scenes is over 12 gigs. One of them is about 10.5 gigs of VRAM usage. So that's giving a bit of an edge to the 3080 Ti because it has just enough VRAM that it's not having the same penalty that 3080 is. ArcViz uses a lot of VRAM. That's like their number one thing because they're throwing in just massive textures. They're not usually doing ray tracing. They're usually baking all their lighting.
Okay.
Which is like calculating the lighting and putting it into a new texture that then is applied on top of the base texture, kind of like a multiply layer in Photoshop. Okay. Then they bake those at like extremely high resolutions and not reuse them. In game dev, you usually reuse the light maps, so you have less of them being rendered, and you usually make them really small. So yeah, all that stuff means that they're using a lot of VRAM. So that's why you're seeing a big gap there. And then virtual production, this one, the gap's not as big, and that's because virtual production has a bigger range of use cases.
Oh, okay.
It could be like a lot of the live production, like someone standing on a stage doing a presentation. There's very little geometry in the scene, very little texture usage. So it doesn't take a whole lot of data. And then you have The Mandalorian, which needs huge amounts of VRAM. So it kind of, the scores are balancing out there because there's one scene that takes no VRAM or takes like 2 gigs, another one that takes 20. So then here's a graph I made just the high VRAM usage stuff. So if you're, this scene uses, see at 1080p, it uses about 15 gigs of VRAM. Okay. And at 4K, it's about just over 20 gigs of VRAM.
Wow.
While this is running. And there's like spikes depending on the angle of the camera and stuff and how much stuff's on screen at the time. Wow. Because each of these is like a 1 minute like fly through of level. Oh, and that's how I average the frame rate over that whole time to get the what the score is. So yeah, as you can see in Unreal, VRAM makes a huge impact. If you're going high VRAM, like you really need to get the 3090. And you can actually see the 3060 actually has a pretty big jump up over the 3070 because of its 12 gig VRAM. Like it's just enough that it actually does pretty well. In
even though the performance of that card is quite a bit below 3060 Ti.
Yeah, but that VRAM was just enough to help it out.
Wow.
So yeah, but if you're looking at like the Mandalorian type workflow, you're gonna want to. Well, you're probably gonna want a Quadro, but you're gonna want a 3090.
Yeah, I mean, if you're doing Mandalorian stuff, you've got the budget that like,
yeah,
you're gonna be getting whatever the highest end stuff is.
Yeah. You're gonna. I mean, you're gonna need Quadro just for the sync, anyways, and all that kind of stuff. Yeah, I thought this was pretty interesting because this is the first time I've gotten to like be able to single out VRAM usage on a scene. That was a lot of work to get that.
It's kind of remarkable to see just how much of an effect that having that VRAM available makes. That's really kind of shocking.
Because what does it have to do if you don't have enough? Because like you said, one of the scenes is 20 gigs of VRAM, but yet you're running it on an 8 gig card. Does that just mean it has to delete unused or delete stuff that's not being actively used and then have to reload it next time?
It overflows into the shared memory with the system RAM.
Oh, okay. So it overflows into system RAM.
Yeah, that's why it keeps going, but the performance drops so much is because now it's having to go back and forth between system RAM through the CPU, and that just is a huge slowdown.
I see. So that's also probably one of the situations where like PCIe 4 is actually beneficial because it's having to go across so much.
Probably.
I would imagine.
Yeah. That'd be an interesting thing to test with. I could throw this on an older system and see what it does.
You should be able to limit the PCIe gen in the BIOS.
That's true. I could just.
You can also use the whole the sticky note method I've used for changing the number of lanes.
Make it
just got to count the
electrical.
pins and cover the pins.
Yeah.
Oh yeah. I remember doing something like that.
It works.
The X8 works.
Yeah. But yeah, so Unreal, it's if you don't use the VRAM, it's basically a 3090. If you do use it, then there's no replacing the 3090.
Wow.
Oh, and then the other thing I should mention, if anyone is considering this and might be using higher VRAM, we did experience some stability problems with the 3080 Ti, and we're not sure why. We've been in contact with NVIDIA, sent them my scene and everything for them to look at. But that exact same system with the 3080, 3060, 3060 Ti, whatever, ran fine, but you put the 3080 Ti in and it would crash. So we're not sure why.
Weird.
And I think the other thing,
that's a driver. The drivers are weird for this.
Yeah,
one.
that's the other thing we should probably mention is that the driver is really weird. So the driver for the 3080 Ti and the 3070 Ti, when you look it up, it only lists as supported hardware. It only lists the 3080 Ti, 3080, 3070 Ti, 3070, 3060, and 3060 Ti. It does not list the 3090, and it doesn't list anything older than the 30 series card. So the 3090 is on one driver, and then the 3080 Ti is on a different driver.
Yeah, that sounds like it's not a fully developed.
Yeah,
that's weird. Huh? I don't know enough about how drivers work, but why would they have to do that?
I mean, it's not unusual for a launch driver to only support like a few cards, but it is unusual that it supports everything but one.
Yeah,
right.
And that's only
the one that's basically the same card.
And it's only the studio driver. The GeForce driver supports everything, or the Game Ready driver.
Okay.
But it's the Game Ready driver still has the same stability problem. It still would crash. And I'm not sure why, because I mean, it sounds like driver, obviously, but it's probably driver specific to that card because that driver with a 3080 would run fine.
Yeah.
But that driver, the 3080 Ti. So I think it's just they're not done with that.
At least hopefully.
Yeah.
Hopefully it's not like the VRAM's overheating because, I mean, you guys check temperatures and everything. And like VRAM runs hot these days.
Yeah.
But it wasn't any hotter than anything else. So
yeah, I think it got to like 70 something C when it crashed.
That's not
pretty okay.
Yeah, it only crashes like maybe I think it's about 35, 40 seconds after the scene starts that it crashes. So like it hasn't had a lot of time to heat up.
Yeah, we'll see. Hopefully it's just a launch bug. Launch bugs are not unusual. It's a little bit strange on something like this. That's just like a bump in specs, not something new.
Yeah.
Launch day bugs are
Yeah.
Not unusual.
But I mean, if you're thinking about using high VRAM, then you should be looking at the 3090 anyways. It's only $300 more, and you're going to get. I mean, look at the chart. You're going to get way better performance for that price. Like,
yeah.
But if you're not,
assuming you can get one.
Yeah, true. Yeah. I mean, take what you can get, really.
Yeah.
Buy from us.
But again,
you can get one.
we actually have supply, so we actually can get people to 3090s. Because are we selling the 3080 Ti's yet? I don't remember if that passed qualification yet.
I don't know if they're on the website yet.
Yeah, they might not be.
Because
how, I guess for people watching, like how it usually goes is labs, we get like first dibs on the cards because we need to figure out like where is this worth qualifying up for and everything like that. And then our qualification team look at it from like noise, thermals, what do we have to do in order to actually put it in our systems. So I think it's still in that section for us.
Yeah, I wouldn't be surprised if they're still looking at thermals with how hot it is and like how many can we do, all that kind of stuff.
I know we already have a few cards in inventory, so as soon as they pass qualification, we'll be able to get them in.
Nice. Is that the last bit for you, Kelly?
That's it for me.
All right. How about you, Don? What have you got for us? This will be kind of like brand new, right? Because I don't think you've put any articles out for graphics cards
posted
yet.
This. I haven't. No, I'm still testing the thing. Yeah, I just started my testing this week, and I'm refreshing stuff. It looks pretty interesting, and Kelly, thanks for putting that up. We're showing the memory difference because I didn't really show anything where that really stood out. But yeah, the thing with the memory, when it makes a difference, it makes a big difference.
Mm-hmm.
And in the scientific stuff, when you run out of memory, it's just heartbreaking, that OOM error,
Mm-hmm.
and also for the AI stuff, the machine learning stuff, if you look historically at a lot of the models and stuff like that, especially like with the image training and stuff like that, they use these really fairly small images. And part of that, the reason behind all that historically is just that GPUs didn't have a lot of memory. So if you're trying to do something like you're looking at maybe medical images, 3D images, you had to jump through a lot of hoops in order to deal with the lack of memory. So when it makes a difference, when it is a showstopper, it's really a showstopper, and it can make a big difference. And it's also interesting because that memory is very expensive, and so like that doubling in of the memory up to the 3090, I would have expect that price gap in there to be bigger than what it is, that $300 or whatever.
Oh,
but 12 gigs is a pretty nice spot. It's pretty reasonable for a lot of stuff. So yeah, I think it's a good card. I'm pretty much in agreement with everybody else that it's essentially like a 3090 with less memory. There is some differences in here, and there's pretty subtle stuff too. On the Linux side, all my stuff's in Linux. On the Linux driver side, latest NVIDIA driver 465, something like that. The 3080 Ti, and that's a recent. I mean, that's just very recent. It still comes up as graphics device. It's not reading the idea of from the GPU yet, but it worked fine. And in fact, in a way, it was even better. And I didn't have any. I didn't run into any problems with it on the driver side as far. But this was just pure compute that I did.
Okay.
So, yeah, you want to put the stuff up here? I can go through this. Does my mouse show up? Oh, it doesn't. Darn. Yeah. Okay. That just so everybody knows, I'm the scientific computing advisor. So scientific computing, hardcore number crunching, and molecular dynamics, quantum chemistry, machine learning, AI, all that kind of stuff is what I look at. So I'm looking at it as a compute device, not as the system I test on doesn't even have a GUI.
Oh.
Okay, so this is all just compute. But the first thing, and probably of most interest really, is how is it for machine learning kind of workloads? Because that's, I mean, GPUs drove that whole thing forward.
Oh yeah.
I mean, the MLAI revolution would not have happened without NVIDIA GPUs. This chart, I wanted to put this up, okay, because for a couple of reasons. The green, okay, the two green are the 3080 Ti and the 3090. Right. And this first benchmark is a residual network 50-layer ResNet. It's a good model. It's a good standard for a benchmark. And this is basically just grinding through images per second. This is a convolutional neural network for usually used for image classification. Okay. It's a good.
This is your classic. What does a fire hydrant look like? Kind of thing.
Yeah. Or I mean, it's a good network. It's a good model, and it's fairly beefy. But I kind of wanted to illustrate and here you can see the from what I was running, the little numbers in the parentheses or the batch size. Okay. And a lot of times the batch size makes a bigger difference. I'm actually going to redo the 3090 stuff a little bit so that those numbers may be a little bit bigger by the time I publish this.
Oh, okay.
But I have to wait to get back on the system because it's down right now. So you can see there kind of a relative performance. And just as far as like kind of where this fits in things, the 2080 Ti was venerable. I mean, that was like a standard GPU, and a huge amount of work has been done on those. And so I've got down there at the bottom, I've got a little bit older result on a 2080 Ti. And you can see how much difference the newer GPUs. So like a 3080 Ti is a great replacement for a 2080 Ti based machine learning dev platform. You could put 4 2080 Ti's in a box without a problem, and you're not going to be able to do that. This thing it's what, Matt? Is this like 320 watts or something like that?
Sounds right.
350.
Yeah, it's equal to the 3090.
In the chart, I thought it was even
in the chart that Matt was showing. It's 350.
Well, I remember too. TDP is.
Oh yeah.
Right.
Yeah, these things are performing because they're just like really juicing them. And they don't need to. They could power these things down, and you only lose a few percentage. And I know that for a fact, right?
We've done that, yeah.
I've done that.
Yeah, they've just gone the direction of throttling when things get too hot, rather than. Yeah. It's the same way CPUs have done it too. Like your boost clocks are not sustained; they are short term. And it's expected that it will go down. Like it's abnormal to be able to keep these things up, and same thing with GPUs.
Yeah, it's annoying. The thing that I want to point out here on this chart is, okay, we're looking at GeForce card, which is your bread and butter gaming card, really good for applications that have GPU acceleration, like what we've all been looking at. But NVIDIA makes a killer compute card, the A100, that what used to be called a Tesla. That's only for compute. There's no video output on it. It's a passively cooled card, so it's got to go in a rack, or have special kind of cooling. But you can see those things are just killer. And I've got all the way up there to 4 A100s, and insane performance. They're very, very expensive.
Oh yeah.
I don't even know, $10,000-$12,000, something like that. I'm not even sure. Maybe not that much. And those are 40 gigabyte cards, by the way. So memory becomes, and there's an 80 gigabyte version of it. So that's a whole different ballgame, and that's what you find in GPU accelerated supercomputers. But man, GeForce cards, 3080 Ti, whatever, it would be a great card for a machine learning rig.
So the A100, I just tried to look it up. MSRP is $24,000.
Oh no way!
A little more than 10.
That's got to be the 80, right?
No, it's 40 gig.
Oh my goodness. Okay, whoa. Okay.
I could only find it in one place.
Yeah, I think that's probably not what we would be selling them for.
Maybe this. Well, this one only says 12. I don't know. Maybe that first listing was wrong. So maybe it's like, because
I think
24
12,
seems like a lot.
I feel like between 12.5 and maybe 20. Yeah, depending on.
Yeah, I think
if you can get them,
it's probably closer to 12.
CDW is trying to sell them for 24.
Oh man, okay. We know how this stuff is going right now, right? Oh, that's insane. But yeah, they're pricey, but man, are they great! And for some things, they're insanely great.
But you could buy 20 3080s.
That's the whole thing.
Right, that's crazy.
That's why NVIDIA was so successful, is because this desktop GPU turned out to be killer for compute, and it was perfect for machine learning. And that's what caused the whole thing to explode and go forward. And that's why NVIDIA is in the place they are. So they don't really like you doing compute on GeForce, and they might take offense to me mixing a chart that's showing but they should be happy to see that A100 up there, because it's insanely great.
I mean, it's like double.
Yeah, it's
one to one.
Insanely great. Wait till wait till I get down the chart a little bit. But yeah, man. I mean, this is reality. So many people have learned machine learning AI stuff on a GeForce card.
Yeah.
I mean, it would not have happened without it. So, it's really important. The next benchmark here, and this one definitely needs to be repeated. I would have done that like yesterday, but the machines are down because of some electrical work being done in labs. But the 3090 will do better than this. This is the FP16. This is the half precision. This is where tensor cores come in. Standard tensor cores come in on like the GeForce GPUs.
Okay.
They're lower precision, but they offer way more performance. This is like 12. This is like 1.2 teraflops. Well, it's not teraflops. It's images per second. Okay.
Yeah.
But that's more than double what it was in the single precision, the FP32.
Which makes sense.
So this is
right?
tensor cores kicking in, and it makes that's a really, really nice thing, a nice feature in the NVIDIA GPUs. And a lot of stuff you can get away with this FP16, with this half precision in certain parts of a calculation. If you lose too much precision, things can blow up. Okay, they either underflow or overflow, or they just get so much accumulated error that they're garbage. But NVIDIA's done a lot of work on mixed precision. So you can have lower precision where you can get away with it, and then you have higher precision where those errors become more critical. NVIDIA's ecosystem for compute is tremendous.
It's weird to see the 3090 turning in a number less than the 3080 Ti.
Yeah, that's one that I need to repeat.
Okay.
Yeah, this chart, I just put these up here so I had I could show this stuff. These are not final results.
Wow.
Yeah, and I want to make sure I want all this stuff to be on the same. I'm using NVIDIA's NGC containers for this. This is TensorFlow. That's NVIDIA's latest NGC container, and I need to redo that 3090 on with that container and at that batch size.
Okay.
Okay, so that number is a little bit deceptive. It will be, but it's just for this size, it's fine. The extra memory is not really being utilized. It's not going to make that much difference in here.
Oh, okay.
In fact, on this, a lot of times I see if I increase that batch size much more than this, then it doesn't improve performance on the 3090 for some reason. It really does on the A100. It makes a big difference. Okay. But anyway, so that's what's going on there. So that's kind of the machine learning AI stuff. It's a great card. 3080 Ti. Yeah, if you're looking at that, totally recommend it. And like Matt said, you know, that extra and Kelly, you know, that extra 2 gigabytes over the 3080. Yeah, that's nice, man. That opens, you wouldn't think that it would make so much difference, but it really, that little bit of extra is so many times it's like what you need. Mm-hmm. So yeah, good card. I'm pretty impressed with it. Now here, this one, okay, I love this one. Okay, because this is a GeForce card. Right. GeForce cards historically do not have good double precision. FP64. That's the standard for scientific computing. CPUs default for any kind of, like, you know, engineering scientific stuff. It's default to use double precision.
Okay.
That's 64-bit floating point. And this is the LinPack. This is solving a big system of linear equations. So this is pure numerical linear algebra. It's the bread and butter of what happens for almost all it. AI stuff does the same kind of calculations. Okay. But they usually don't need the double precision, right? Okay. But scientific work, a lot of times, yeah, that's a showstopper. It's kept people from diving into GPUs early on, because it was just like not possible to do the level of calculations that needed to be done on the GPU, because you could not do it in single precision. But that's what NVIDIA's compute cards are insanely great for. And that's why you see those crazy supercomputer performance numbers. Because the HPL LinPack is what the top 500 supercomputers are generally, that's their principal ranking number, is the performance there. And this number up here is 41 teraflops. That's 41 trillion operations per second. Okay. And that's for the A100s. And you notice that scales really well too, right?
Yeah.
The Titan V on here, I should point that out. That was Volta. Mm-hmm. Volta was another NVIDIA compute card that they only made one GeForce card. Mm-hmm. That was the Titan V. And there was only 2 cards that had active cooling: the Titan V and the Quadro GV100.
Uh-huh.
But their Volta compute is like really, really good. And so this Titan V, you can see how really good it is, but you can also see that's 2 of them right there. That first Titan V number. And one A100 is significantly better than that 2 Titan Vs.
I mean, that Titan V is pretty old now. Was it like 5 years old?
It's back there, but man, the Volta GPUs are still cranking.
I mean,
you go
those scores. It's crazy.
Yeah, they're good. I mean, it's a good card. But yeah. I mean, the new stuff is so much better. When NVIDIA does a new compute GPU release, they've been doubling it every time. I mean, it's just insane how they can keep doing that. It's crazy. But you go down the chart, you get down to kind of this first kind of, I wish you could see my mouse, but oh crud.
Oh, there it is.
Oh, hey, that worked. Oh, good.
Saw the finger at least for a second there.
Oh,
that's all right.
Okay, whatever. I'm sorry. The dual Xeon there are really great. The best CPU system I've ever tested, and it's about 3 teraflops. Okay, so you see why GPU acceleration is so important in high performance computing.
Yeah,
it's harder to do. Okay, this is not. It's not. CPUs are great.
right.
Okay, but yeah, when you can get GPUs cranking on your code, it can be stunning, the performance. But yeah, you go down, you get down to more CPU stuff, and you get down to these 2 little green bars down here, and that's the 3080 Ti and the 3090, and they're both about the same, and their performance for double precision is like, way down there. Okay, it drops down crazy. And that's just traditional. They just don't put those resources on those chips. That's the chip. The GPU itself is GA102 on those GPUs. The A100 is on the GA100 GPU, and it's completely different. There's a huge number of features on the GA100 that it's not like the others at all. But you can see that that's down in the performance of more like an 8 or 12 core CPU, which is not bad, really, if you think about it. Okay, because now you've got that extra stuff there. But anyway, so that's like scientific computing. Oh man, this thing. Oh, that's why it did that. Okay, there we go. There. Okay, now there's another one very related to this, but this is at lower. Oh man, we're over. I'm sorry.
Yeah, we're over time.
Lightning round.
Okay, the lightning round. The HPL AI is lower precision version of that same benchmark. Okay, and they've recently added this into supercomputer testing because machine learning is becoming very important on supercomputers.
Right.
And when you do this, you see these numbers go way up down here. This is now 15 teraflops on that 3080 Ti.
Yeah.
Okay. Compared to 500 on the double precision. Okay, so yeah, the single precision on these GPUs is great. But of course the A100 is like, blows it away. I have a 0 there for 1. And I have a special note here on the 3090 because those actually failed residual error tests when I first tested them. If I run the 3090 with the same problem size as I did the 3080 Ti, it's about the same. But if I make the problem bigger, which usually increases performance drastically on GPUs, the 3090 gave garbage.
Weird.
Okay. Yeah. And that's what happened on the A100, single A100. This 3090 did the same thing, but the 3080 Ti, no problem. It gave a good result at single precision on that benchmark.
Weird.
Okay, so that was kind of cool. Yeah, the last thing here is to look at memory performance. This is again one of the big deals for GPUs. What? That sounded like Ludo. No? Okay.
There's an airplane going over.
Oh, okay. Sorry. But anyway, here again, the memory performance on GPUs is killer. HPCG is the classic benchmark for memory-bound code, and you can see how much better these little teeny bars down towards the bottom are CPUs. Okay, the GPU GDDR memory is just fantastic. It's really, really fast. And again, but the 3080 Ti has got the same GDDR6 GDDR6X, like extra good, right? As the 3090. And so the memory performance is really about the same, and it's very good. It's not in the same class as the A100, but really excellent. So that's computing on this thing.
Yay! Right on. All right. Awesome. Well, I feel like from our angle, the 3080 Ti isn't as bad as the enthusiast sort of industry kind of made it out to be. I saw a lot of YouTube titles and stuff about like how 3080 Ti is a piece of trash, it's garbage, don't waste your time. And it seems like
good.
At least for what we're aiming for the folks who tend to be or surrounding our content, it's not that bad. It doesn't.
I think there was some. I think there's some debate on should they have released another GPU when they are still having such trouble with the other GPUs. That hurts the enthusiast a lot. Like, just keep making stuff.
Yeah, but this could totally just be your bin 3090s. It probably is. Right. It's 3090s that didn't make it. In the past, they would have called it a 3080 and sold it. Now they realize, like, oh, we can actually get a little bit more out of it, so we'll call it a 3080 Ti. I bet it's not affecting total GPU count at all.
Also, like, there is a VRAM shortage, just like any other chip. And if they can take slightly slower 3090s and make two of them instead of one of the 3090s, like, that helps. So
like when Intel released a bunch of new SKUs with they like disabled the integrated graphics, but it was still basically a high-end CPU.
Yeah, or there's the 10850K instead of the 10900.
Yeah,
it's just ones that didn't quite make it, but they don't want to bend it all the way down to the lower end model. So let's put it in this in between, and let people get it. It just gives people more performance. I do think it is priced a bit high.
I think
for
so
what
too.
it is. I would love if it was right in between 3080 and 3090, rather than being $500 more than the 3080 and $300 less than 3090. It'd be nice if it was just right at 400.
Yeah,
but
or even 300 then 500, because like the only people that need the 24 are high-end content creators or machine learning things. Like you're buying $10,000 systems. They're the only people that really need it. I don't know. The pricing is a little weird.
But if they were like spinning up new fab and like completely making new things just to release a 3080 Ti, it'd be stupid. But since it's just taking failed 3090s and binning it, like, it's not wasting anything. It's not. There's nothing. There's no cost to it, except I suppose in the past it would have become a 3080 that people could get for cheaper, I suppose. But it's just which way do you put it?
I think the memory thing is an issue, like Kelly was saying, and it, hopefully that this will actually just increase the supply of GPUs that are available.
Yeah,
that would be like great, right? So let's hope that's what the result is.
Yeah, and in theory, this is supposed to have that hash rate limiter, so it shouldn't be as desirable to cryptocurrency miners. We'll see if that actually is true or not. And if it is true, then that should help these get to gamers versus crypto. So we'll see. Like,
I'm so open. Like, a lot of the mining stuff, they're supposed to be moving to proof of stake, but until they all do, they'll just switch over what they're mining from Ethereum to Bitcoin or whatever.
Right.
That was my conclusion, was that that save these cards, save the 3080 Ti for the gamers and get yourself a 3090. Go ahead. If you're at that level, then you probably want to go ahead, and then you've got that extra memory, because when you need it is a big deal. So that was kind of my bottom. It's like, but still, it's like whatever you can get. Right. So
awesome.
I have a lot of people in the virtual production community who are buying A5000s because they can actually find those cheaper than 3090s right now.
That's crazy.
Like, if you're trying to buy them on the third market,
because an A5000 is equivalent to like a 3080,
but with the 24 gigs of VRAM.
The VRAM,
So for virtual production, they're like, it's fine. Like, we'll use that. We need the VRAM more than everything else.
All right. Well, I think that'll be
Well,
one more thing, Matt? Go ahead.
Yeah, I saw someone ask a question about power draw, and like, oh, are we concerned about power draw and everything? And like, are we gonna have to start liquid cooling stuff?
Oh, yeah,
Can you
yeah,
share
yeah.
my screen real quick?
Yeah, sure. Yeah, I'll pop up that question real quick before we go. So, Rakesh asked, if the VRAM size and heat keeps going up, will it become a necessity to water cool GPUs in the future?
Yeah, and you don't remember probably this card, the 3090 X2 from AMD, that had 4 8-pin powers, and the power draw, the wattage was 580 watts.
Oh my god!
So
Jeez.
this is not the highest we've ever been before, because this was back in 2015, and back then we also had the Titan Z. That was like, oh, actually no, I brought it up, didn't I? That was 375 watts, so even that was higher. That was in the days of they would put 2 chips on a GPU, and it was basically dual GPU on a single card, and we didn't have to liquid cool those, so we probably have room.
Yeah, I think we'll be all right.
Air cooling is actually can be really effective.
Yeah,
Well,
but
and
those cards were just nuts. But really, it doesn't look that much different than like the modern cards we're
I
using.
know, isn't that crazy?
So the 3090, part of the reason that its VRAM gets so hot is that half the VRAM is on the back of the card.
Yeah.
So it's
Mhm.
only being cooled by the back plate, not by active cooling from the fans. And it's
Yeah.
still, it's hot, but it's not crazy. So
I just love this.
yeah.
That's
Oh man,
crazy.
4 8-pins. Ugh.
Yeah.
All right.
All right, sorry.
No, that's all right.
That's
That's
great.
I'm gonna have to draw a hard line here. I know we did get one more question in here toward the end, but so I'll say perverted angel mark. Hit up Don on Twitter, and we'll cover that question there. But thank you guys, everybody, for taking the time out of the day and joining us today. This will be just kind of an interesting. I mean, it's just another like step along a very interesting path that we've been on for like a year plus. So thank you guys for sharing your results with us today, and thanks to the audience as well for joining us and sticking around. And yeah, if you guys have anything else you want to say,
No.
Yeah.
all right, then we'll just say goodbye. Thanks, everybody. Tune in every Friday, 1 p.m. Pacific. We do this sort of thing with internal and external experts, and we'll keep doing it. As long as you keep watching, we'll keep streaming. So we'll see you all next time.
Yep.
Bye.
See ya.
So long.